Okay, here's the most important thing I can say about logs. A logarithm is really like a man-made thing. Like mathematicians decided to write it like that so that we didn't have to write down all the words. You know how mathematicians are kind of lazy. But the thing that really gets people about logs is that they never really take the time to figure out what it means. Once you figure out what the log means, it really isn't that bad. But you all have to agree to speak the same language that we mathematicians are speaking. So you got to understand what log means. A log is a way to talk about what the exponent is. Okay, so that's why we have the definition of a logarithm written in context with some exponential equation. So I'm going to first talk about this stuff over here on the side that is new to us. Okay, this right here is what a log looks like. A lot of times you'll see the word log, but I'll talk about in a few slides. The natural log has its own abbreviation, but generally logs are logs. This B is subscripted. Sub meaning below. So this is not on the regular line of text, and it's not the same size as the other text. It's just kind of like an exponent, but it's down below. Okay? And that's the base of the logarithm, right? So you'll know what your base is. Just by looking at that, you can see it. Okay? Then there's some number y. That's the thing that we're going to take the log of. And when we take the log of something, we get some answer, and that answer is an exponent. So to say a phrase like log base b of y is to ask the question, what exponent do I raise b to get y? So it's asking me to answer exponent. Now, I'm going to write this down. I always like to know when my math teachers are talking what they're actually saying. Sometimes I get confused by that. So this little piece right here is read as log base b of y. That's how you read that. There'll be numbers in there eventually. Like you might say log base 3 of 9, log base 2 of 12, log base 1/2 of 1 over 32. You can put all kinds of numbers in there. And this statement is only true, so we have the if and only if b to the x is equal to y. So again, this is asking the question, what exponent do I need to raise base b to get y? Weird, because I have two 2's right next to each other. What exponent do I have to raise base b to get the value of y? The answer to a logarithm is an exponent. If you could leave the room today with one little bit of information, I think that's a really good one. The answer to a logarithm is an exponent. Now, I'm going to show you right here log base b of y equals x. I like to sort of draw a little swirl. Really mathematically a thing, but some people like it because it helps them rewrite it. So if I'm trying to take log base b of y equals x and rewrite it as an exponent, start at b, because that's your base, right? Okay, so start at b, there's the base to my exponent. The swirl always goes around the equal sign, so then you pick up your exponent x. So it's b to the x equals that thing that's on the inside. So it kind of swirls into itself. Why? If you like this swirl, you can kind of follow the swirl to help you rewrite things. If you're like, I don't need the swirl, I got it, that's cool too. Either way works. Some people just like to kind of have a visual to follow. The important thing about this swirl is you have to go out of order. You got to go around the equal sign. It doesn't just go from left to right. Yep. So let's see. What does this mean then? We're going to get some equations that are already done for us. We're going to rewrite the equation in exponential form. So first one is log base 4 of 16 equals 2. All of these things are true. It doesn't mean anything to you unless you take the time to know what a log actually means, right? The answer to a log is an exponent. So when I say log base 4 of 16 equals, this number right here is my exponent. The answer to a log is an exponent. What's the base of my exponent? 4. That's the base of my log. It's the base of my exponent. So this rewrites as 4 squared equals 16. True? Yes. So again, remember that question I have at the top of the screen. The log base 4 of 16 is asking the question, what do I need to raise 4 to get 16? Well, I've got to square it. That's the only thing that works. 4 to the first is 4. 4 cubed is 64. 4 squared is 16. So the answer has to be 2. Kaylin.
So, like, what is a log? Like, is it just, like...
It's a way to ask the same question. What's the exponent?
Okay.
It's just a way to ask that question, yep. Why they decide to write it like that? Don't know. Wasn't there. Didn't get a say. We could manufacture our own secret way to ask the question about what's the exponent, but then no one would know what we were talking about because everybody's agreed to this form. So, okay. Now, most common wrong answers I get on quizzes and tests, just FYI, I get a lot of this. And I think it's just because people see it from left to right, and this sort of looks like it's being raised. This is just laziness, though, right? Not paying attention. And, like, stop and think about this. Is 4 to the 16th equal to 2? No. It is a very big number, and it is not equal to 2. It shouldn't go from left to right in order. It's the swirl. 4 squared equals 16. Okay. So let's rewrite log base 9 of 3 equals 1/2. Base is
9.
9. What's the exponent?
1/2.
1/2 equals
3.
3. Does that make sense? 9 to 1/2 equals 3? Why?
It's like
Oh, yeah. Raising something to the 1/2 is really a square root, isn't it? Okay, so that's good for us to know. So that's really saying the square root of 9 is 3, and we agree with that. That's a true statement. Okay. Rewrite the other two for me. So I move them up. After you rewrite them, stop and look at them. Do they make sense the way you rewrote them? First one, 3 to the 4th equals 81. True? Yeah. Next one, 2 to the negative 3 equals 1/8. Does that make sense? Yeah, because what do negative exponents do? They flip things. They might flip a fraction to be not a fraction, or they flip things that aren't fractions and then they look like fractions. Yeah, it makes sense. Remember, negative exponents don't make anything negative, right? that's really helpful to us too. Okay. So it's like always go back to this if like it all makes sense now when you're in room A08. And then you'll like maybe take a break and go home and do your homework and you'll be like, what's a log? Right? So go back to this part where you rewrote it and just try to remake sense of why we're writing it the way we're writing it. We're asking the question, what exponent do we need for this base to get the number that comes behind it? Okay, so now we're going to do these logs without a calculator. Eventually I'm going to teach you how to do logs in your calculator, but you should know how to do some logs without a calculator. Some logs we can't really do without a calculator. So we're going to start with log base 3 of 27. Remember, the answer to a logarithm is an exponent. So I always like to draw my little thought bubbles here. Like this, what's happening in my brain right now. Right here. I am thinking base 3 raised to some exponent, so I'll put a little question mark up there, equals the number 27. What is that exponent? 3. I'm going to let you chat out the last two there. These are a little bit tougher, but I think you could do it with your pods, put some brains together. See what you can come up with. Can you evaluate those other logs without a calculator? Draw my thought bubble if you need to. Okay, I got some thought bubbles up there of what we're thinking about in our head, right? We're asking ourselves the question, what is the exponent we need for this particular base to get this number that comes after the log and the base? So, anybody got a good argument for log base 49 of 7? Kaylee.
1/2.
Why?
So since it's going from a higher number to a lower number, you need to square root it, or you need to root it. So then you have to think backwards, like 7 to what equals 49 in a second.
Yeah, I think I love what she said. When you have a big number that goes to a small number with an exponent, there's probably a root involved. So you're probably going to have something in the denominator of your fraction. Good. Yeah, so that would be 1/2. Did any groups decide an answer for log base 5 of 1 over 25? Aiden, what did your group say? Your reasoning? Why? Yes. Jacob?
So 5 squared is 25, and you need it in the denominator, so you make it negative to flip it.
Yeah, so like I would say like going along with like Haley's idea there, like on the 49 to 7, it was like a bigger number 49 and then all of a sudden it got smaller, so we must have rooted it, right? We're not really seeing that issue in terms of 5, like we are seeing it get bigger to be 5 squared, 25. But we should notice if your base is a regular number and then all of a sudden your answer is a fraction, you know there has to be a negative exponent at play, right? So then we know that's that negative exponent that flips it. Okay. Okay, I got one more. Log base 36 of 1/6. See if you can come up with an answer. There's a bunch of stuff happening, right? It's going from a whole number to a fraction, so there's a negative exponent. It's also, like Haley said, going from a big number to a small number, so there's a root. So we would say negative 1/2. If there's a different root, like a cube root, remember that would be like 1/3. So you could get those different answers. Okay, so if I ask you to do anything without a calculator, it has to be something that like you could think about, right? So, but you might need to think about those things about numbers getting smaller, so using fraction exponents. You might need to think about flipping things, so you might need negative exponents. Not too bad, right? It all makes sense now. It's good. Okay. There's two special types of logarithms that you should know. They have sort of like little nicknames. They're called the common log and the natural log. And the reason why these are special is they're used a lot. I was going to say really common. That's why that was called the common log. They're used a lot. So the common log is a log base 10. You know, just think about, you've already learned scientific notations. So anytime we're using scientific notation, you know, a log might be helpful because it's a way to think about what the exponent is. This gets used a lot like in terms of sound, like with decibels. Also the Richter scale that measures earthquakes uses some logarithms in it, base 10. Now, the important thing to note about the common log is it can look like this. Log 100. And I don't even have to write what the base is. If you see it just log 100, you know it's base 10. So, like, we don't always write the base for the common log. It's just like the square root, right? When we finally did nth roots in chapter 5, we saw the cube root and the fourth root and the fifth root. We would write the little number on this side. But if it's a square root, we don't always have to put the 2 there because everybody knows it's a square root. So that's the same thing for this log. Now, you can write in the little 10 if you want to. Let's evaluate this without a calculator. What would the log of 100 be? 10 to the 10 is 100. The answer to a log is an exponent. So we're wondering what exponent do we need for the base, which is base 10. Okay, we're thinking in our head 10 to some exponent equals 100, so 2 is our answer. It's not multiplication, it's powers. Okay, and then of course we also have something called the natural log. That's base E. Of course, this one's super common because we talked about like E is so common for like population and different growth things because most things in nature don't work on schedules, right? They compound all the time. So we need to be able to undo that as well, and that's going to be the natural log. Now the natural log has its own abbreviation. I always make my L curvy, so you know this is not an I, this is not a 1, this is an L. Why it's LN, I don't know, maybe I was like French, log, natural, something like that, right? So think about your foreign language when you put your adjective behind. It's natural log. You could write a capital L. It's really a lowercase l, but some people write capitals. If I wrote the natural log of E, okay, what is the base right here? E. So we're wondering, E to what exponent equals E? The answer would be 1. Okay. So the natural log of e is 1. Okay, now these should have buttons on your calculator. So can you please look at your calculator? I know some people found their E in that PRV menu. That's where you're going to find your log and your natural log. But most of us, we used second ln, but we're just going to type ln when we want natural log, right? Don't hit the second. We don't want E, we just want natural log, or we got log. Anybody having trouble finding their logs or ln's, natural logs? Okay. See if you can evaluate these with a calculator.
What about log, right?
Did you have E? Oh, it's right over here.
Or my E
Well, actually, I would use this E in the future. Like, did all your things work out with that E?
Yeah.
Oh, okay. This one, I don't know. Did you have to make your own exponent on that one? Like, you had to hit the exponent button.
Yeah.
If you do shift natural log up here,
Oh, yeah.
it will bring the exponent for you. It's like E to the something. But if you want natural log, you just want to here.
Oh, okay. Yeah.
Anybody else having trouble finding their log?
Yeah.
Yours is like business calculator, so there's a potential. Oh wait, it's right there. Okay. So you just have to hit it for as many as you whatever you want. Yes. I'm gonna put up my decimals. Oh. Oh, okay. Let me put these up, and then I'm gonna come around and check anybody who's not working out. Because we should all get the same answer. So make sure your calculator works. And with logs, it's common to go like 3 or 4 numbers after the decimal. So we don't round to the nearest 10. Oops. Yeah, that's right.
Oops.
It might be a rounding thing. Yeah, okay, see when it says 6 on the bottom of your guys's, that means that you've set it to like round it, so it's probably rounding up. So we need to go this second decimal, and see it's saying don't have any numbers after the decimal, always round to the nearest whole number. If you put it on F, it means flow, it'll give you as many decimals as you want. So you're also on fixed. So we just need to find your fixed button. Actually, yours might be. There. Okay, so you do shift, setup, and then you want to choose 6, and you want as many as you can do, so do 9. Now try doing it. I don't know how to make your fix go. Everybody doing okay? Doing okay? Doing okay?
Yeah.
Okay.
Fantastic.
Now, remember at the top of this slide, really important, you can only use this button for base 10 and base E. Now, some of you have calculators that have like the math print, so you'll be able to go in and put bases in. We'll get to that eventually. There's also a formula that you can use to change the base, which I will teach you if you don't have that capability on your calculator. But the log button and the natural log button are only for base 10 and base E. Make sure you know that. Okay. You all ready for your homework?